Hi, we're at Ping Pong Physics, and this is our DP3 presentation, featuring me, Anuj Roy, my partner, Brett Pomerantz, and my other partner, Trevor New. Today we'd like to talk about how far we've gotten and everything that we've accomplished so far. So our mission statement from the beginning has been to develop a BRG machine that will demonstrate basic physics concepts to 4th grade students. We'd also like to talk about how far we've gotten and what we've done up to this point, as well as how the previous reports, DP1 and DP2, have influenced where we are now. In addition, we'd like to talk about the final CAD models that we developed that show the completed product, as well as the product architecture, industrial design, assembly time worksheet, and cost sheet from our project. So here you can see our updated Gantt chart, which shows how we've now completed the majority of our project, and we are now in the final phase, which is presenting our findings and our report overall, as well as our BRG. So tasks A through L have been completed, and now we are ready to complete our final product. So using the Gantt chart throughout our project was a necessary tool in order to determine where we needed to be at each point in the design phase. So making sure that each step was completed on time and that all of our processes were completed within a decent time frame was necessary. So we used the Gantt chart in order to make sure that we were in the right place at the right time and making sure that we were meeting all the deadlines that we had previously set for ourselves. So in our report, we actually included DP1 and DP2 to show the overall product and what we had decided to do with the DP3 overall. So in the final report, DP3, we decided to include a few parts of DP1, which included the research of the customer needs so that we knew who we wanted to target and what influenced our decisions to choose the stations that we did that demonstrated the physics topics that we decided to represent. We also decided what the customer would actually decide that they wanted to see in the BRG, so the basic physics concepts that I previously discussed. In addition, we established the mission statement at the very beginning, and we wanted to reiterate that in our final product. As far as DP2 goes, we also included a few elements from there, in which we talked about some patents that were relative to the final product and how they influenced a few of our designs and our stations. We also like to talk about how we developed each station and the CAD models that we made going through with station 1, 2, and 3, and how we decided to finally choose which design we wanted to go with moving forward. Now my partner Brett Pomerantz will talk about the 3D CAD models and how we went about creating them.
Hello. So as you can see on the left here, this is our CAD model, and this is the drawing of the CAD model. Our CAD model has changed throughout time, and this is the finished product. Over here in the purple, we have station 1, which is basically just the spinning wheel into a ramp. And in the blue, we have station 2, which is going to catch the ball and go around a half loop into a pipe. That pipe will then drop down, the ball then drop down the pipe into station 3, which is a guide rail, dominoes / friction station. It will hit the dominoes, which will fall down, and there will be a second ping pong ball right over here. The added momentum from the dominoes will then collapse and push the ping pong ball through here, which is a friction station, which we will be able to change out between like sheet metal, plastic, cardboard, whatever we want. And over here is just the drawing of the whole system, as you can see from the top view, the right view, and the front view. Then the regular view. So industrial design is basically a concept of how well we did, in our opinion. As you can see from the performance ratings, we think that we did pretty well in this BRG, especially in the appropriate use of resources. Based off of the resources and materials, tools that we were given, we believe as a team that we did a very good job in creating a functional BRG that also looks good and is pretty appealing. For the product differentiation, we feel like the addition of the wheel was very good and kind of just a unique aspect to it. When we looked around, we didn't see very many others introducing the wheel. So the assembly time worksheet is basically just how long we estimate that this will take to put together, how long it'll take for each piece to snap together. Over here we have the number of times that each task has to be performed. All of them except for the dominoes will be 1. Dominoes, since you have to put together each domino. The manual handling time is just how long the people you're holding the actual objects and not actually putting them together, trying to orient them in the way to put them together. And then the manual placement time is placing it into the right piece, or putting the pieces together, putting it onto the board. And as you can see from here, we did not take very long. It's a very simple and easy process. This, in fact, obviously does not take into consideration the transition period between putting in a piece and then picking up another piece. And it also does not take into consideration how many times the person has done it and the familiarity with it, as the assembly time will definitely go down as the person has put it together more and more. And now my partner Trevor Neer will talk about the product architecture.
So here we have our product architecture diagram. This is where our team took our completed BRG and broke it into separate chunks based on their functionality. We decided to break our BRG into 7 different chunks. They are base, start, Arduino, station 1, station 2, station 3, and end. Like I said, every chunk is based on its particular functionality. Breaking every single one of our stations into their own chunk gives us the ability to expand the concepts that could be incorporated into the BRG into maybe chemistry or computer science. So therefore, we could expand the scope of what could be incorporated in our BRG by just replacing the station 1, 2, and 3 chunk with different concepts rather than just physics concepts. Here we have our call sheet for the entire BRG project in its final. All the way on the left side we have every single component to our BRG, so that is everything from the Arduino and every single piece involved. The next column is all the what the price of each one of those components is, factoring in the how much material is used based off what it's made out of. Like some of the our components are made out of 3D printed, so therefore it's not going to cost the entire roll of the 3D printed spool to make that piece. Next column is the processing, which is the machine plus the labor. So that would therefore be the 3D printing for some parts. Assembly time, we have 2 parts that require some assembly after being made and or bought. And then finally we have a total unit variable cost, which sums up the purchase materials, the processing, and the assembly labor altogether. On the right side of the column, we have the cost of the machines that it takes to make some of those parts. So the 3D printer and what its fixed cost would be per unit. And then adding the tooling, or the total unit cost and the total variable cost. Total unit fixed cost and the total unit variable cost gives us a total cost over here. And then all the way in the bottom, we sum it all together and we get a total cost for our BRG of $64.21. Next is our toward detailed design, the discussion of future changes. While constructing our BRG, we ran into a few issues with some of our initial stations that we designed. One being the spring station. We came across the fact that a ping pong ball doesn't have enough mass to uh, launch the spring like we wanted it to. So we had to make some changes. Changes that we did incorporate after realizing that the spring station would not work was we transitioned into a half loop, which still incorporates physics concepts of centripetal force rather than spring force. Questions that we would have in the future based off this project is, if we were to do a similar project like the BRG, how would the future project require? Would it require more calculations? Because our BRG was focused more on trial and error runs rather than strict calculations. So maybe a project in the future might require more calculations rather than just repetitive trials to see what would work and what wouldn't work and what needed to be changed. How would we tackle design issues in the future is a question like, how would we tackle, what was our plan of action for figuring out this like a spring station wouldn't work? Like, how do we want to completely change the station? Do we want to just try and tweak it a little bit? There's the questions like for those issues that we encounter in design, like how do we move past the issue or solve it? And then finally, which projects require more research on the customer and related patents before design rather than others? Because our BRG was very heavily weighted on the customer research because we were designing it for the use in a classroom. So we wanted to get a good scope of what would be best for use in a classroom, specifically 4th grade students. So in conclusion, the major points of our DP3 were our final CAD model, our product architecture, the cost sheet, and the discussion of the future changes for the BRG. There was months of research and design that led into these final design phase, but this last phase put it all together, all the customer research, all the many different concept developments, and ruling out what would work and what would not work, into finally creating our final BRG design, which we made a prototype and tested. Ping Pong Physics as a team is very pleased with the outcome of our BRG. We believe that it works just the way we wanted to, and it's great for a 4th grade classroom to start teaching some of these kids at that age what physics is all about, and makes it very fun while doing so. Thank you.